Recording in progress.
Good evening. My name is Wahid Lutfi. Welcome to my YouTube channel, which is MyWebUniversity free educational videos. Please make comments on the website as well as subscribe and watch these videos. You will learn a lot from it. I promise you that. And if you don't learn, make some comments where the area needs to be improved and I'll improve it for your needs. Thank you for watching. And let me just start with tonight's session. So as you can see, I have already have this presentation, which I'm going to do a slideshow first. On the slideshow, you see that I have covered already Python and data structure tuples with 2 videos that we posted. Less data structure, 3 videos, set 1 video, and tonight I'm going to cover set a second tutorial session. The string, class, and objects and data dictionary will be next. But at this time, we have already posted 2 videos on tuple, and then 3 videos on less data structure. And this is less data structure tutorial 1. And you should watch the actual video, which I was already on the MyWebUniversity free educational YouTube channel. And then this is tutorial number 2 for list. And this is tutorial number 3. But this is just a thumbnail. The actual video is like 39 minutes, 44 minutes, 52 minutes, and so on. Python set data structure we covered the other day. And this was the first tutorial that I covered. And a lot of these methods and objects that the double underscore method, spatial magic method, we call it, or spatial methods, or dunder method. We covered a lot of those ones, as well as a lot of the other methods that are listed here. And we also, at the end of the video, on the right side, where this for statement is showing, I basically showed you how to print column-wise the directory listing of this set. And then this is how you do it. But I will go through that one again tonight, because I want you to understand how to get help whenever you want to see what are the methods and double underscore magic method are available to you for a particular data structure, such as set, tuples, list, and dictionary. So this is the topic of tonight, set data structure tutorial 2. We're going to show you that column-wise printing of the dir for set, as well as tuple, as well as list, as well as dictionary. And I'm also going to show you how to kind of make it like a template, so you can get that same kind of structure for any library modules like math modules or anything else. And then set conversion from list to tuples. And that is basically like if you have a list or you have a comprehension list, how you just convert it. How you do summation on the list. Obviously, if it is list of millions numbers, and then you just want to have a faster way to do the calculation. How you do product like multiplication on it, or get the factorial of a set. So, or a number. And then a conversion of list to set. Conversion of list to set is also with the list comprehension. And how to use a while go for length of set to see if it is greater than 0, you keep popping the elements, otherwise you empty the list or the set in this case. Set if one set is subset of another set, and also check to see if one set is a superset of another set. So we're going to cover all of that one on tutorial 2 tonight. Let's just show you my Jupyter Notebook interface, which is the Google collab.research.google.com website. As I mentioned in the past, this is the Google Notebook, Jupyter Notebook, that is giving you basically a virtual machine of Linux that you can just practice Linux as well as Python in here. And you can just run Python code in this interface on the code. and you can write text like this on the top here. For example, this one I'm going to demonstrate to you that we're going to do set data structure, tutorial 2. And here's the code that I have written. And then for more, please subscribe at our channel, which is https://youtube.com/@MyWebUniversity. So if you click on this one, basically you will be getting into this page, and then you will just subscribe or watch videos there. But let's get started with this one. So I'm going to just Control X here, and then run this one as if right now code is there and then I'm not doing anything. So if I just put that code back here, and I want to just say, okay, give me a column-wise 5 columns, 1, 2, 3, 4, 5. 5 columns for the directory for the set. So if I change this one to, let's say, 4 columns, obviously it's going to be a little bit narrower column-wise, and it's 4 of them. You can just change it to as many as you want. That's like you do it 7, it's going to be a little bit wider, and then less number of lines or rows versus columns. So the 5 seems to be very good on this one, because you can paste this information and get it. You can also decide to get it for 4. So 4 is also very nice. You can see the output clearly. All the information is there. But notice that when I say this one, I wrote this for statement to get this directory structure rather than a dir. Imagine if I just was doing this dir of set. And then when I do this print on dir of set, notice on the first line, this is going in one row. But then I have to move my cursor all the way to the right to read everything. So it is not kind of a little bit too clean for me. I wanted to do this so you can have the entire directory listing of this one and one in front of you. So you don't have to move the cursor up and down or left and right. But then the other nice thing about this one is you can just get the same thing for tuple. So I'm just writing this for statement to see if the number is there. If I just want to get 4 of them for all of them, and then I get this one, the same thing for tuple. So notice the tuple is a little bit smaller in terms of number of methods and double underscore magic method are there. The only method that are there is count and index. However, list data structure is much larger than tuple. And so list is a little bit slower because of this overhead, and there's more functions and more things that you can do. The size of how many attributes you're gonna just, how many methods that you're going to run, there are more available here. Similarly, if you go for dictionary you can see it there. So if you just want to get information about the dictionary help, you can see that it is just all the directory listing of those items that are there. Next session, when I cover dictionary, I'll cover a lot of these functions here. So at this time, we're doing set. But let's say you're interested in math module. If you type in math, at this time, math is not imported. Notice if you run this one, it's going to say, well, this one, because previously I must have imported math. But if you don't have a math module or something like sys module that's not loaded, it will just say that this module is not defined. So I must have just done earlier on this session, like import math, or I could have just also done import sys. So here I could say import sys. Now this sys is defined. I can do a directory listing on this one, and it will tell me column-wise there. So this is very good for getting information on anything. So if I just say, for example, get on random, random is going to just say random is not defined. And then I say import random, then load it here, and it's going to show. So it's very useful. If it is part of the library that are coming, like some data structure like set, then you don't have to just load it or import it. Then you can just get that information. So tonight we're covering set. And then if you want to just get any information about set, last time I said that the dir of set will give you the set, and then we created an empty set as equal like set of this, and then print a type of empty set, and then also we say just print the empty set itself. So you could get that information there. Notice if I do a dir of empty set, this is the same as if I'm running dir of set. So this will give me all the set information. Whether I type in dir of set here, set, or dir of empty set, it will run on the same thing. So those two are the same. But let's get started with the rest of the video. That was just something from last time. I summarized it again, so you can get help or directory listing of any item that you want. But on this note, let me just see what I have for you. I'm going to cover. So for demo one, we already showed you the set and items. I'm gonna do this one next. Let's just do this. And I'm going to run this one to make it empty, so you know that there's nothing here. I'm gonna post this one that I already wrote in order to not type the same thing again and make some typos, then correct it and everything. So we already did this one. So let's just run this one. If you run this one, basically, as you can see, this line 1 max is equal 5. And I'm just trying to cover whatever is the number that I'm providing here plus 1. So the range normally does not cover the end 1. You just have to do plus 1. So that number plus 1 will be, range will cover that one also. And then here I'm doing a list comprehension. As you know that when you do the list comprehension, if I just do that line by itself, say x is equal, and then we say a list of x for x in range of max plus 1. If I just do this one and say print x, notice that this one is going to give me the list. So what happened here is I'm going to check on it. For x in range max plus 1, let's see why x is equal x for x in range max plus 1, and then we're printing x. So max is not defined. That's true because I have max in uppercase, and then it's case sensitive Python and Unix. So if I just have this variable as max uppercase, I have to do it here also max uppercase. I could have just simply put 6 here and 6 here. That would be the same as 5 plus 1, which is max. But I wanted to do this max plus 1 just to show you that this formula is a list comprehension. And if I type in print type of x, is just basically is telling me that this is class set. This one, the first one is a list. So x is a list here. So the next one, when I'm doing the online 6 prints, the type of it says class set. But at this time, let's just do one more thing here. I'm going to delete these lines because I just added those ones. And you saw that 0 through 1 through 5 is there. But then in here, I'm doing some sort of calculation that say, okay, whatever is the number, just get me this number. And then at this time, the class set is going to say the type of it. And then the S1 is going to print all the values 0 through 5. And then if I change this one to, let's say 10, the number shows 0 through 9 or 10 here because 10 plus 1. 10 plus 1 is 11, so it covers 10 also here. And then notice that on the rest of the formula, no matter what I put here, it will just do S1 here, which is print all the S1. And then this 55 is just a sum of it. Right here, I do a sum on line 5, and then I just say print it. If I just want to say here the word, I could say the word sum, colon, and then this, and then I could just say, go ahead, print that one in front of it. Now notice it says sum here. And if I just make, instead of sum, right, like total, then you will get the total here, 55. But then later on, I want to set a variable to total 0. So I can go within a for statement, and then I'm going to check for the item in S1, which is this 0 through 10. Each one of those items, if the item is 0, I will just continue because I'm doing multiplication. I don't want to multiply the number by 0. When you do continue, you're going to break out of this loop, and then it's going to go to the next line. So the next number is selected because you don't want to multiply any number by 0. You will get the wrong product. This formula will not work because any number multiplied by 0 is equal 0. So you will get a 0 here if you don't do this. But notice here, I'm doing product is equal 1, and then multiply it. So I get a product here, and as well as a summation for total plus item. In total, we start with 0, so we don't add any number like 1 increment of 1 more. And then if I print this one, notice this number, the product of it is really huge because this number is 10. If I change this one to, let's say, a 5 factorial would be 120, and that's also product of it. So this product is the factorial of the number, as well as 5 times 4 times 3 times 2 times 1 is 120. Similarly, if I get this one to 4, and that would be 24, and 24 addition of it. When you, I mean multiplication of it or factorial of it. But if you do addition, that is 1 plus 2 is 3, plus 3 is 6, plus 4 is 10. And you can see here the total that is showing here for the sum function, where I'm passing on a sum function, which is Python sum. It takes the set S1 and then just add up all the numbers here. And then the same thing, we could do it a for statement within our sum, and this total plus item, it will just do it. So our sum in Python sum is the same, except we're using a for statement to traverse through the loop to just find every item in the set and then add it. And then the sum, this one will do the work recursively for us in there. And then similarly, we are also multiplying it so we can get a product or the factorial. So if I just say this one is 3, 3 times 2 is 6, and times 1 is 6. And so that product should come to a 6 here, which is there. And then the addition, 1 plus 2 is 3, 3 plus 3 is this. Now notice this number, if you just change it to 100, this number is going to grow really huge. And then you can see how big this number is for the product. So sometimes Python allows you, especially Python version 3, that allows you to have a max integer as long as the computer supports it. But eventually you will run out of memory to store to big number. So you just have to be careful to say that what is the product of this one. And then if you just say, for example, 20 here, and just that is also a big number, but again, this one is much more manageable. Or if you just change this one to 15, for example, let's see if 15 is, yeah, 15, you can see that this one is there. I can even put this one in a short video, and then you could see the entire thing here. So let's just do a second example of the same thing. I'm going to show you a second example here. Let me see this one. Yeah, this one I'm going to do Max range plus 1, we already, oh, this one, the only difference between this one and that one, notice this one is, I'm using type is 1, demo 2. Let me see, make sure that I'm putting the right one. Max 1 plus 0, and this one is a pop. I don't want to show you that one yet. I want to do this one. Yeah, actually we did that one already, so the numbers are okay. Here you can also change this one to a smaller number. Let's say like you can do up to 7. So first you get the value 7 here, but then in the formula for less comprehension, you could say to the power of 2. So any number you get to the power of that number, and notice that the numbers are 1 and 2 to the power of 2 is 4, 3 to the power of actually 1 and then 4, and then whatever was that number times that, because the order, notice that it's in set, you don't get the order. 3 would be this number, 3 to the power of 2 would be 9, and this would be 6 to the power of 2, 6 times 6. This one would be 2, and this one would be 4, and this one would be 7, and this one would be 5. So you could get that list of the values. But if you just multiply it to the power of itself, that number to the power of x, this number will increment exponentially, because you can see how big those numbers become. Except this one is 3 to the power of 3 is 27, 2 to the power of 2 is 4, and then 5 to the power of 5 is 31, 27, and so on. You can see. And 1 to the power of 1 is 1. So let's just, and then the summation, and then every computation we're doing here, you're going to see in the result here for the product of those ones. And let me just do this second demo. I'm just going to see if I go on total product. We got the total product, and then type is, yeah. Let's do this one. Max is equal this one, and then while let's just link this as one set. Okay, so this one, I'm going to clean out this information here. And if I just do this, you see that there's no code here at this time, and I'm going to paste this code. And what on this one I want to show you is that you can do less comprehension again to get all those numbers between 1 and 6, 5 included, and then run the type and then run the set. But this time we're going to pop the elements from the length. If s1.length is greater than 0, then we keep popping. Once we reach to the end of it, then we just print the list, that list is empty. So if I just run, notice that this is my list here, 0, 1, 2, 3, 4, 5. And then notice that element that are being popped is 0, 1, 2, 3, and all the way to 5 gets popped. And at the end, when I print on line 10, I print, and it's going to just show basically the set is just empty. So let's see if we could just change this formula a little bit. We do to the power of x, say the same numbers, and see how they are calculated. Notice that these numbers are there. You might have thought that, okay, when we pop, it's always like working like a queue here, the first in, that first out, because you're seeing that this was in the list first and this one second and so on. But this is not the case. Set does not have any order. So the way that the orders are entered, it's not like a list or tuple that they have indices. Since there's no indices, these numbers could be entered randomly in an unordered list. And when you're popping, it is whatever it shows on the last set, it will just pop it in from the front, as if it's like a queue or first in, first out, FIFO. But again, set is not ordered. It's unordered. They're distinct element and so on. So in order to show you some of these other numbers, you might say, why is this 1 there, 0 is not there when we started with 0? But let me just show you one more thing here that I did just to show you. So here, I'm going to show you this one. So if we look at this code, as you can see, line 2 through 5, I did some print statement, and I wanted to say 0 to the power of 0, or 0 to the power of 1, and 1 to the power of 0, and 1 to the power of 1. As you can see, 0 to the power of 0 is returning 1, and 0 to the power of 1 is going to return 0, and then 1 to the power of. But in this case, we're only doing one time 0 to the power of 0, which is 1. And then the next time we're looking at the next number is 1 to the power of 1, which is also 1. So when we print this 1, it is this one and this one, but because it's a set, it only prints one of these ones. The other one is discarded because we cannot allow duplicate elements. I just wanted to make sure that if you see this one, and this is an order list, so it is not in the front. Similarly for the other numbers to the power of it, and eventually we are going to get 256 for 1. This one is again for 2 to the power of 2. This one is 5 to the power of 5, and this one is 3 to the power of 3, and so on. All of those numbers, you can see that the code is working as expected. So this is not like if it's not working, it's working fine. And if I just want to get a smaller number up to 4 and run the same code here, and notice that this is there. Similarly, I don't need this print statement anymore. If I just do this one for the max of 8 and then just get those numbers, you can see that the numbers are coming and it is popping there. But again, if I do this one for a larger number, it is gonna just go big. So just make sure that this number, because we're just getting the list larger and larger. If this formula was simple, like x to the power of 2, the number does not go exponentially, so it is not that big. But when you do to the power of itself, so the number is 15 to the power of 15, it is this big number, and that is going to come in. Similarly, if we go like 20, for example, again, I don't want to do it with 1 million or something, because you could just slow down your system for the calculation itself and everything. Sometimes when you do regression testing to make sure what is a performance that you can get it, you can practice those ones on a test machine, not on production machine. So let's get it with 5 here, and we're good with this example, and then we see everything working. So let's show you, let me show you the second example. I'm going to the pop, we demonstrated that one. Oh, the pop, the length function, I just want to show you right here, we did the S1 length of it. So you can also do S1 dot and double underscore length, a magic method or a spatial method that we call it, and double underscore length. So when nobody wants to read the double underscore on both sides, you just say the length spatial method or magic method. And that works like as if you're doing len on S1. That was the same thing as the syntax earlier I had, length function and S1 on it. That would do exactly the same thing as that one. Okay, so that was it. Let me just clean this one. I'll show you some more. And then this demo that I'm going to show you next is we did the length function with pop. And let's do this other one, which is max. We did this one, the print statement also for those ones. And notice that with this example, I want to just put one more information here because I want you to understand the while statement. The while statement here, as you can see that I'm just checking while length is greater than 0, keep popping. So if I just don't want to get the last item to pop, then I could say greater than 1 or something. But notice the while statement is that this condition is true. As long as this condition is true, then it's going to be done. And then when that condition is true, false, then we print the S1. And then at this time, we are going to just say the set S1 is, and then we just do single quote here, and then print it. Notice that after the while statement is terminated, the indentation is on the next line. I'm just doing it. Notice here it says that set is now empty because this one does not have any element in there. And last time I showed you like how to add it. For example, it's one dot add. You can just add 5 to it. And then you can also do it's one dot double underscore add, and then double underscore, and then 5 to it. Another 10 to it. 5 is already in there. So then you could just say print S1. And now after this set was empty, we added 2 elements there. Let's see why it was just saying that one. So the add is saying that you have to add a number, which is like a 10 here, and then let's see, add dot add is one dot add. Let's see if the so if that did not work, you can just print this one 5 first, and then you know that 5 is added here. But then if you just say print help of on S1 dot and double underscore add double underscore, and notice that double underscore add double underscore method is so far not showing up. Yeah, that method is not showing up. Object has no attribute of add, but there was an add method. So the add is already, we did it there, so we could do that one. But you could also do an update here, say for example update, and then provide another set. So we could say it's one dot update, and then we could just say, in this case we are going to create another set, which is this brace, and then we can just say 1, 2, 3, 3 and 4. So since those are there, we could just say print S1 now. Let's see if those numbers are added here. But notice if I just add 2 one more time, that is not going to be inserted twice. When we insert this one, this is still unique numbers. So you cannot just say that since I put it this one, it's there. And last time I showed you also the data type is important. So if you insert a string, that is different than just inserting. So this 2 is an integer, and this 2 is a string. Similarly, if I put the insert true here, and then notice that I could just get those values. True is there. Let's see why the true was not just inserted. Set 1, 2, 3, 4, 5, and then 4. The true should be added here. Let me just say print. S1 dot add, and then I'm gonna just say true. So we're just going to get rid of this one and just add it like that and see if that adds it. Yeah, it added. And then here, why it did not add it? Let's see if we could just say false here, and then just see if the false get added. Maybe I had a typo. Yeah, maybe I had a typo somewhere. So this one, if I just make this one false, and then this one true, it should have been added somehow. Maybe I had a typo or something. And then let's see if we get both of them. Wow, the true is becoming like a statement inside this update list, and it's not getting added here. But false is getting added, maybe because of this space. Yeah, false is no, it's not a space. If I make this one a string, it will add it. True, and then true is getting added, but not a value like this. So then the other thing is, let's just say here we're going to add s1.update update, and we're going to say a list of not list of elements, or let's not add it, we just do it with add, and then we just say the string true and the Boolean value true. We're going to add that one, and then notice this one is true and false and everything. So now I'm going to do one more thing here for item and s1. We're going to just print the data type, print type of s1 item, just to see what it is, and then also print item. So for each item, we get the data type and print it, and you can see they're Boolean, the true and false. The other one are integer, and then the last one is a string, which is number 2. Number 2 is a string. So let me just clean this one up and show you one more here. Let's see what I have here. Okay, this one is a nice one. We're going to check for a set. If one set is a superset of the other set, or a set is a subset of set. So with this line 1 through 13, basically I have two sets. The first set is S1, which is 1 and 2. The second set is 2, which is all this 1, 2, 3, true, and Python is cool. And those are the elements of set 2. Then we are going to check the set S1 printed, and then also S2, which here says the set S1 is this, and the set S2 is this. So that's the result. Now the if statement is going to check if S1 dot is subset of S2. So, and we're saying that basically the set S1 is a subset of S2. If that is the case, then it should print this statement. Let's see if that was the case. The set S1 is a subset of S2. Is that true? 1 and 2 is included on this set 1 and 2. Therefore, it is a subset of S2. And then the next statement that says that set S2 is a superset of S1. Since the second list contains 1 and 2, is a superset of it. So you can see that this statement and the set S2, this last one, S2 is a superset of S1. When you're checking on this one, if S2 is a superset of S1, basically say that if the set S2 is superset of S1. It's not the other way around. If this is not S1. So now if we just check this one, make this one, let's say, true, and then we just say, if we do this one, notice 1, 2, and true is there. Still, this is going to hold. But if I just make this one more statement and say 5.5, because none of those ones are going to be the condition. So one set is not a superset of the other one, and one set is not a subset of the other one, because they have different elements. But if I just take this 5.5 and just say Python is cool, true 1, 2, and then I add 3 here, and then just say Python is cool, the same thing, Python is cool, and then just run this one. So both sets are the same. Both sets are the same. Let's see, the value of them are just going to match with all of them. S1 is a subset of S2, S2 is a superset of S1, S1 is a subset of S2, and so on. So all of the condition, and then this case is going to match, because they're exactly the same. One could be containing the other one, which is a superset, and the other one could be a subset of it because every element of that one is also on the other set. But if I just now change the order of this one and make the other set, say, just contain this one here, and then obviously the output is going to be different. The set S2 is only one, but now S2 is a superset of S1. S2 is a superset of S1. The set S2 is a superset of S1. That's not true, because S2 only contains one, and one contains this. So somewhere here, the superset, I might have just put the order wrong here. So S1 is a superset of S2, and then S2 is a superset of S1. Why this one did not get it? Let's see. S2 is a superset of S1, and this is S2, this is S1. S2 contains a 1, is a subset of 1, superset. For the superset, I have as superset as superset. S2. Oh, S2 contains a superset of S1. This one, and then S1 is a superset of S2. So S1 is a superset of S2 is correct, but S2 is a superset of S1 is not correct. So S2 is a superset of S1. Why is this one showing up here? If S2 is this one is a superset of S1, and then S2 is a superset of S1. This one, let me just change the wording here. The set S2 testing, just the word, let's see if that is statement testing. Yeah, somehow this thing is coming from somewhere else, because this is not true. It is coming from the other one, test. Why is that? It did not read the code at all. Let me just run it. I think maybe it is from leftover. I did not run it, maybe. S2 as a superset of S1. The set S2 is a superset of S1. It comes with this line. Oh, because of the FS statement, it's there's no else part of it. That is why. Sometimes when you don't have an else part of it, and then you're not doing this one, the code is running that line, disregard to that situation. So I'm going to just say else, and then say print false. Let's see if this one prints false, then we know the else part. Yeah, this is going to print false. So this is correct. And then in here, we could just say another else, and then print false. So we could add these ones just to say that that is not the case whenever that is not the case. And then we just say else here, and then print false. And here also else. So the else part, also we have to test for this condition to just make sure that our code is working fine. S2 is a superset of S1. S2 is still not a superset of S1. This statement, why is it coming here? Let me comment this one. S2 is a superset to see if it is coming from this line or somewhere else in the memory. It shouldn't come out at this one. That condition is not true. Unless the set S1, even though I have one here, it is just getting the range, but the values are not accurate. S2 is a superset. This one is coming from somewhere else. Superset, oh yeah, right here, I have that statement a couple of times. Is, oh, right here. Okay, I found the problem. So even without these faults, and they should have worked. The typing, sometimes a typo is the hardest part of your code. You just have to correct the typos and make sure that you don't have any typos. Let me just delete these lines and then I'll just correct the typo. Here I said if S subset, the S2 is a superset. I should have said it's a subset. Subset, that is accurate. These two are for subset testing, and this, so the word superset was coming when this one was a subset of it. So some other example that I showed you here, if you see those errors on the video that I'm not going to go back and modify them, just ignore the wording. The wording was off, because when you check for subset, this is string for some reason, or this is string was for some reason was mistyped. Instead of subset, I wrote superset. So now it should work correctly. And you can see that S2 is a subset of S1, and S2 is correct, a subset of it, and S1 is a superset of S2. So this is how it should have worked. The wording here, I accidentally typed superset when I meant subset. Similar, like right now, if I just change this one to 2, then you can see still you get the same kind of result here. But if I just change this one to BS2 and this one to BS1, now notice that this is going to be changing. S1 is a subset of S2, which is correct, and S2 is a superset of S1, which is correct. Okay, I hope you liked it and enjoyed it and learned something from it. So at any time you have any question, please make comments on the video, and I'll be more than happy to just make another video and help you out with your questions. Thank you so much. God bless you. Have a good time, and don't forget to watch the World Cup. And then go to MyWebUniversity YouTube channel, subscribe, because with your subscription, it gives me more time to just make better videos and make it available for you. Currently, I have more than 600 videos. You're welcome to learn Unix, Python, shell scripting, C, C++, on all of this one for free. It's similar to college courses, but it is just online on YouTube for free. And you should enjoy it and learn it from it and watch them. Take care. Bye-bye. Oh, God. Let me just close it. And I hope you guys have a great time. Bye-bye. Pause, stop.